For this question, we have a transformer used to step down 120 volt RMS. Okay. Oh, by the way, whenever you see this kind of rating given, right, it's already the VRMS. Okay. It will always be VRMS unless stated otherwise. So back to the question. So this is connected to a transformer, step it down, and then to a 3 ohm resistor. So we are supposed to find the current in the primary coil. Okay. So there are many ways to do this. So one of the way, right, is to see that when you step down this voltage, you have 120 volt here. Step down 20 times, so you get 6 volt. So since this is an ideal transformer, so the V input will be equals to the V output. Okay. V input will be equals to IP times 120. P equals to IV. V output is simply, right, 6 square divided by 3, and that will give us 36 divided by 3, 12. Okay, yeah, and the IP will be equals to 12 divided by 120, so 0.10 ampere. So that will give us D. Alternative, right, is to find the secondary current. So once you know what is the V secondary, so you can find what is the I secondary. So this equals to Vs over R. So that gives us 2.0 ampere. Then, right, you can step it down, okay, in the primary circuit. So the IP divided by Is equals to Ns divided by Np. Okay, so IP will be equals to 1 over 20 times of 2.0. So this is also workable, but you got to realize, right, they are actually the same method, because how this one come about is because we have the for ideal transformer, ISVS equals to IPVP. Okay, because the power is the same for input and output, because no power loss in the ideal transformer, and that gives us, right, ISIP equals to VPVS, which is in turn equals to MPNS. So you see, this equation, right, arise because of ideal transformer is saying that power input equals power output, and that is the same as what we have done earlier. So although we are doing a different steps, right, in both method 1 and 2, but the underlying principle are the same.